Okay, we're live again with another Infinite Layers. Today, we are joined by an AVS team who's been building on EigenLayer Automata Network. I'm here with a couple of the co-founders. So thank you guys so much for your time today, for joining us. Looking forward to learning a lot about Automata. Do you mind giving us intros to yourself, and then we'll dive into what you all have built?
Yeah. Hey guys, great to be here. Thanks for the invite to Infinite Layers. I'm Deli from Automata. I'm one of the co-founders. So actually, I joined crypto in 2016. Start reading like some of the white papers. Also like have better understanding. At that time, I was a student at National University of Singapore, doing a little bit research on system security and network security. That's also why I have interest in crypto in general, because it's really like rhymes really well with the research area. Especially at that moment, I started learning about trusted execution, basically the technology we've been using. That's also when I met Zhenlong over there. So it's kind of like everything all started from there. So ever since then, we started like really like talking about how to use TE to bridge the gap in crypto. So we started the project in around 2020. We actually, during COVID, we had to work from home, trying to discuss ideas. In 2021, we launched projects, did a fundraising, like all the way until now. Yeah, great to be here again.
Okay, then I think Deli said a little bit about myself. So for me, I kind of like finished my PhD during late 2018, early 2019. And kind of like during my entire PhD research, my focus has always been on system security, specifically more on the kind of like lower level stuff like binary analysis, program analysis, privacy, attacks on systems. How can we kind of like break certain security assumptions? So I remember back when I started my PhD in 2013, when I first entered the lab, we were talking about like designing our own trusted execution chip. Back then, the Intel didn't have their Intel SGX. I guess the only kind of like trusted execution environment that was commercially available was ARM Trust Zone, and then that kind of like started my entire journey of like playing around with TEs. So, yeah.
So teas, this has been something that for me it's fairly new, but the more I learn about them, it's not a new idea. Like this idea has kind of been around, and it feels like it's come in and out of the discussion around how people are architecting different systems. And now it seems to be more of an interesting topic, or more of like a popular topic. So before we dive into Automata, I would love to talk about teas, for example, to get started. If someone was to just ask, what's the definition of a trusted execution environment? What would be the answer to something like that?
I think the simplest kind of like explanation that I give for a trusted execution environment is really like it's a private piece of it's a kind of like private computation space that you can have away from the machine that you are working on. So you can think of it as a remote. It's like an extension of your computer that you're using on some remote server or some remote location. So it allows you to perform computation as though you're running it on your local machine in some other place. So yeah.
Do you have anything to add, Deli?
Yeah, I think the easier to understand example is I remember I saw this multiple times when we read some of the TE papers and also presentations. People talk about like cloud computing back then, and TE would be a kind of a better model because like you really previously you have to trust clouds, trust that they are not playing with your data. But if you have TE, you could just eliminate the trust because you are not trusting operators anymore. You're just like using technology. You're kind of in trust the enclave that's been running like elsewhere. Also, there will be a mechanism for you to verify and provision your own data. So it actually starts from zero. There's nothing running there, but when the time you provision your data, it becomes kind of your personal like compute like space. So you could just like continue using it for the future. Yeah.
So what are the sorts of things that people are doing within a trusted execution environment, and in the sense of like a use case where I might be building an application and there's a limitation within my smart contract, and then I might offload that to a T? Like, what would be an example of something that might be done there?
Yeah, I think we can talk about that in two like areas. One is in traditionally like in the Web2 industry. Actually, if you look at what Apple is doing recently, they have this private cloud compute, which essentially use cloud-based TEs. Although it's their own kind of architecture based on their own operating system as well. But the concept is similar. So it extends the trust like domain trust boundary from your personal device like iPhone, iPad, Mac to a cloud environment. So from there, you can do like inference because those are like you can't really run it locally. So you have to like put it on cloud to have more powerful like computations. So in Web3, I think in the past, we have seen people doing like really global encrypted state, essentially a private blockchain with private execution. So nobody can really see the transactions. There'll be like ways to also like provision your own data as well, just to store it on blockchain. Also, we've seen people doing a little bit on the oracles, because like TE could like ensure the integrity of the execution as well as the data. So it would be a kind of best fit for like running oracles as well, because it can get data from like trusted source, then post it on chain, and everything can be verified by just checking the signature. I think lately people have interest on multi-prover, because it's kind of a like balance between trust and also the the security and also the cost. Because if you, for example, if people are doing a zero lab, you're already like to run an entire prover system is kind of costly. You certainly can't like do another prover just using like all the system again. You have to use a different tech to kind of mitigate the single point of failure or issues. So this would be some of the use cases we have seen so far.
Yep. And then to kind of like add on a little bit more, I mean, other than like having the functionalities, a lot of kind of like traditional companies like Web2 organizations, they have been using TEs as a way to mitigate some of their own organizational risk. So for example, if I'm a company that and I want to like perform some analysis on my users' data, right? Right now, what happened is that the company would collect the users' data and then perform analysis of it. Of course, the company would have a privacy kind of like agreement with the user to say that like how is the data being used, it won't be sold to third parties, etc. But as we all know, things happen, companies get hacked, and then data gets leaked, and the whole thing becomes a very tricky situation, because the company might not want to review the user's data, but now the data is in the hands of the hackers. So by utilizing trusted execution environments, because the data is actually kept encrypted within the enclave itself, it actually makes it a lot harder for kind of like malicious third party to access the data. That's one. And another one is in the entire like Web3 ecosystem, especially for in terms of like securing what's it called, encryption keys, we actually see a lot of like organizations, for example, like Fireblocks, they actually make use of TEs in a MPC kind of setting where I mean, other than using NPCs to separate out, to distribute the secret shards for the encryption key, they also make use of TEs to ensure that all this and access control to the encryption key is actually enforced by code itself instead of by the operator, because the TEs would guarantee the integrity of the code, which includes access control to the data. And this kind of enforcement is actually done on the operator and the service provider too. So it's a kind of like code is law kind of situation.
So I guess in terms of what Automata is providing, are you all? It doesn't sound like Automata is a trusted execution environment. You're like a platform for people to launch and deploy and manage their own. Is that correct?
Right. In a broader sense, that's actually the better definition, because we don't really develop like TE hardwares. We're actually making use of all type of TEs. So I mean, and up until now, I think we've seen so many different cloud providers, also like chip vendors. They already invented their own TE solutions. I mean, these are already generally available. So that's what we do. We kind of figure out a way to plug it into the Web3 systems. So there are actually multiple ways to do it. And currently, our focus is just like TEE coprocessors, because this model is essentially extending the trust from like blockchains like Ethereum to from the hardwares to Ethereum, so that people can verify hardwares on chain. And if you can verify that, then you don't have to trust any third parties. Kind of the risk is minimized. You can just check the data submitted by the enclaves, and also have certain extension based on that. So this is essentially what we do. Yeah.
So what does the actual experience look like for someone building on Automata? If they're a developer, how would this fit into their tech stack? And what would the process kind of look like for them to kind of say, okay, I want to build my own trusted execution environment. I want to build my own coprocessor maybe or whatever. What does that kind of look like?
Yeah, if you ask this question like 2 years ago, I would say it's still very challenging because like back then, the only kind of commercially generally available solution is Intel SGX. But the security model is a little bit like I would say it's better, but it's also like limited, because you have to really like do some like close integrations between your business logic along with the security model that Intel SGX adopts. That means you have to really think about like what kind of compute would be put into the private like sessions, and what would stay outside. But now things have changed because like a lot of vendors developed this VM-based approach, like AMD, SEV, and also Intel TDX. These are kind of easier solutions to work with. In general, the experience now is if you have some code already developed, we can just take a look at it, figure out like if could be just like put in easily. I mean, in general, it should be fine, but you would probably see some like overhead. I mean, in terms of performance. So we could like look at it and maybe do some optimization to make sure you don't actually lose too much. But compared to other tech, I think like the performance drop would be still acceptable. It's not like really like that serious.
Yep. And then the kind of like what's it called? Developer experience really is it's kind of like mixed. It actually depends on the type of trusted execution environment technology that you choose to that you want to use. So, for example, like on our AVS, we actually support like Intel SGX, TDX, AMD, SCV, AWS Nitro Enclave, stuff like that. So if you choose to like, if you want to use Intel SGX, then the kind of like the bar to actually develop the enclave would be a lot higher. In that case, it's more like a kind of like collaborative effort where we will actually help the project to kind of like co-design how would the kind of like trusted portion of your of the code would be, the untrusted portion, actually which part of your business logic should actually be moved into the trusted segment. So that's like for the Intel SGX portion. And then like for like what Tully mentioned, the kind of like confidential VM solutions like TDX and SCV, it's a lot easier to develop because for the developer itself, they would just write any kind of like standard applications. Of course, when they are writing the applications, they need to have that kind of like mental model where their application will actually be running within a kind of like a sealed pod, so to say. And what we are providing to the application developer is this entire infrastructure, this framework, where we are able to kind of like perform the attestation, the verification that their workload is indeed running in a trusted, genuine hardware. That's one. And two, you have heard about like attacks on like Intel SGX, where hey, some security researchers have actually found out certain vulnerabilities, and Intel might actually take some time to perform what we call a TCB recovery. Is something like, hey, this particular version of the TEE is now unsafe, so please update to the next version of the TEE. So the kind of like current ecosystem now, we actually have to rely on Intel to perform all these TCB recoveries. But what we are doing at Automata Network is really to provide you with the ability for the community to actually step in at an earlier moment to say that, hey, I think this particular vulnerability is serious enough for us to say that these particular versions that are affected by the attack, we are not accepting the kind of like attestation for all these version until there's a particular mitigation or there's a new version. Then we would continue accepting the attestation. So our infrastructure allows projects to actually tap into this.
And like trusted execution environments, they're not really, like you mentioned, limited to blockchain infrastructure, right? This is something that's already existed in the past.
Yes, correct. You're right.
What does the verifiability kind of bring to the table? I mean, in my head, I understand because I can kind of do the same analogy between traditional servers and maybe a blockchain or something. But yeah, I'm curious, like, what might be the value proposition for someone that is going to consider building an application and using a trusted execution environment to kind of understand maybe the differences between the two, between like a traditional TEE versus maybe like something built that's verifiable.
Yes. So actually, when we look at a lot of kind of like TE applications that's being done now, the verification is actually not done by the users, because most users they do not have the technical ability to actually perform the verification itself. So the use cases, at least up to now, where TEs are used, is actually a kind of operator versus service provider kind of situation, where I'm a service provider. I have some workload that I want the operator to run in. So I would pass. I would, and I'm not sure if the operator will actually run my workload properly. So I'll ask the operator to run my workload, and then I'll verify that this particular environment is indeed trustworthy by kind of like performing the remote attestation verification. Once I'm confident that this is a correct, this is a genuine platform, I can then say provision some secret into the environment to do encryption, decryption. I can put some private data in to perform some computation. TEs are used in like Blu-ray decryption programs. So there are some Blu-ray software that actually make use of Intel SGX to perform the decryption. So only when the kind of like the attestation pass through, then the software would release the key into the key itself. So
okay.
Yes, and the reason why it's designed this way is that most users what we believe in is because most users can't actually verify the authenticity of the TEs itself. Now, what if we have this kind of like public infrastructure, like a blockchain, that allow us to have some code that we agree that would that has certain integrities that's enforced to it, and then now we actually perform this kind of like verification publicly in the open and put it again publicly on the ledger itself. This actually allows anyone to have to actually make use of any cloud compute in a way like they are using it on their own machine. They have certain integrity guarantees to a certain level. They have certain privacy guarantees, again, to a certain level. And it's easy for users to use, because users don't actually have to perform that complex protocol. They just need to go online to the smart contract and take a look at, hey, is this machine that I'm talking to attested, verified? If it is, then I can trust the machine. I can trust the results that is coming from the machine.
This is very cool because it's kind of, oh, I'm sorry, go ahead.
Yeah, and we actually also named this thing like proof of machinehood. So it kind of established, we don't call it identity, but more like authenticity of the machine on chain. So it's a proof and people can verify. If you verify the machine, some of the compute on it can also be trusted. So this is why we name it this way.
Yeah, I was just gonna say, like, this is definitely outside the scope of what I'm typically, used to building with. This is like more, I wouldn't say like low level, but it's kind of more, I don't know, I guess it almost reminds me of hardware engineering to an extent. I don't know, because you're kind of talking about actual hardware and things like that. Whereas I've been more, of a full stack developer and now getting into some smart contract development. And then now with EigenLayer, maybe building out a couple of examples of just verifiable networks. But this is just a whole new area that's completely new to me, and it's really interesting. I'm really interested to know like why you all decided to build this product specifically. Like, do you feel like this is an area that's going to have a lot of growth? And if you do think that, I guess, where do you see that growth happening? Like, what specific verticals, maybe?
Yeah, I think at the moment, what we see like interest, like it can come from use cases like multi-prover and also maybe oracles. So maybe I can start with like multi-prover. I mean, it's not a new concept we created. It's actually it's mentioned by Vitalik like in one of his talk in 2022. He mentioned about like because like zk systems are still early and could be vulnerable to like soundness issue. So there must be some ways to mitigate the issue, and like a different tech stack, a different implementations, a diversified implementation would actually help a lot with that. And that actually it's already like become a kind of established opinion in even like the Ethereum client, because you see a lot of other like many different third-party teams develop like clients as well. So similar situation could happen to maybe the prover system. So I mean, before those code can really like formal verify and like maybe audited, an easier way to like start using them is really just have this kind of like more robust and like defense in-depth systems. Like multi-prover is actually one of this. And use cases like oracles is also like especially very powerful, because we've seen so nowadays everything is go by API. So like traditionally, in Oracle, or you have some node grabbing data from API, then post it on chain. But in the world of TEE, you can have a layer of like verifications going on. Basically, because all APIs run through HTTPS, TEE is actually a very good middleman on like verifying the remote party and also relate it to blockchain. But essentially, like create a bridge between like blockchain and also the endpoint. The endpoint can be verified because the cert there is public. You can run some logic to make sure this is always the same cert that you're accessing, instead of like kind of attack like the one that's being replaced by attacker. So this is establish a better like data source kind of trust. Yeah.
Yep. And then I would like to also kind of like push the boundary a little bit. So like what Teli has been describing has been like what we traditionally understand of trusted execution environments. Like I have an environment where I can perform certain computation. Now he actually mentioned something that we are working on, which is called proof of machinehood. Think about that. If I have a trusted execution environment or like any hardware-based secret, then I'm actually able to kind of like because it's hardware-based, I can have a certain level of trust on it, and then I can slowly extend that trust up the entire tech stack. And you might be asking, hey, what can I do with this hardware trust? Like right now, we actually live in this kind of like world where there's more and more content that is generated by AI that people probably can't tell nowadays already. Now think about it. I think most of us have smartphones, either Android phones or Apple iOS phones, and so for example, for every single Apple iPhone, there is a secure enclave chip that is embedded within the device itself, and through that chip, we are actually able to kind of like have a hardware root of trust. Now, if I can extend that hardware root of trust to content that is actually created on my device, I can actually have this like provenance chain, right? Like if I take a piece of if I take a picture or I type a message, now I can say that, hey, this content is actually generated by me, or at least generated by this particular device, right?
So that's going to be extremely important. I mean, it already is starting to become important, right? I think we're already getting to that point. So is that something that's enabled like conceptually through Automata, or is that something that in practice that you think is going to happen? I guess my question is more around, okay, you can extend these sorts of products into existing chips, or do they have to be essentially new hardware that would enable and facilitate something like this?
So I believe this would happen with or without Automata, but we want to be in the position where we can kind of like be part of this. Exactly, yeah. Yes, be part of this movement. So there's actually a move, not a movement, a kind of like a group called Creative Authority (CA). That is kind of like it's a kind of like Web2 movement where device manufacturers, software vendors are getting together to kind of like work on a standard where we can embed all this kind of device specific information that is derived from you can think of it as a hardware root of trust into content that is created, like your camera sensors and things like that. So what this is my personal belief. My personal belief is that like maybe 1-2 years or maybe like 5 years in the future, you'll find this in all your like digital cameras, where if you take a piece of picture, there'll be this chip within the camera that will actually sign over the picture that kind of like proves that this image is taken by the device. Now, if we are talking about a phone, then the nice thing about a phone is that it is more or less a kind of like general compute that is in a kind of like mobile form factor, and we can actually write software that can make use of this hardware secrets or this trusted execution environments to perform certain computation when we are generating the image. So, for example, I can today I can actually write a camera app. On iPhone might be a little bit difficult because of how locked down the API is, but let's say I'm able to write a camera app that can have access to the sensor, and the app can actually, when the user takes a picture, performs a signature over the image that is generated by the camera sensors. And if you perform the attestation from the chip itself to the application, to the operating system, to the firmware running on your device, then you can have you can have the confidence that yes, there's nothing weird about this. This is a genuine Apple device that has unmodified bootloader, unmodified operating system, updated to a particular OS version number. It's using a particular what's it called? Camera application, say XYZ camera app of a particular version. So all these are information that can actually be generated. And then, but you might be thinking again, hey, then wouldn't that be like a kind of like downside for the user's privacy? Because right now, this kind of like hardware attested information, a lot of my information is actually released to the public, right? This is where like zero knowledge proof can actually come in, where to prove to someone, I might not need to actually review that hardware information to that someone. Yes.
You can essentially provide the proof without showing the exact information. Just you're kind of combining both together. Yeah, makes sense.
Yes, exactly, and that is why at Automata we are also kind of like we we have actually implemented some ZK circuits using RISC-0 to actually perform all this verification within the circuits itself. So users can actually have that option, whether they want to take their attestation report, put it on chain and do everything publicly, or they want to use their report, generate a ZK proof for it, and then upload the proof to the chain to kind of like show that they are running certain computation on a genuine device. So there's this option.
Right. I think just to add on that, because Chinlong just covered like how to prove that certain content is generated, not generated by AI, but actually even for AI, there's also a requirement to verify if certain content is generated by the correct version of AI, which is kind of the like model provenance, because it's hard to solve because there's really like no mechanism right now. You have to trust the provider whether they're really running the GPT-4 or GPT-3 version.
You're right. Yeah,
but
that's awesome.
It's possible that like they could just cheat and try to like get you to pay more, right? Because you can't really differentiate like from the quality. But if you like, actually we've seen this. NVIDIA has this like new capabilities built in their latest version of GPU, like H100. They have TEE functionalities. If you couple it with a confidential VM, you could actually establish a like very strong guarantees from the hardware all the way to the software stack. So you can literally trust that a particular model is actually running in that device, on that GPU. So therefore, the content created by it or the inference it's done is also correct. You could just know that this is really coming from a GPT-4 model instead of GPT-3 model. So it's really also useful. I mean, this is something that people have been trying. Even NVIDIA is working with a lot of cloud providers to make it available, so people don't really have to like build the entire thing, because this couples really well with the cloud model, because you could just like start using them. It's also a private like environment running there.
So this has been really helpful. I'm very curious if you all have thought about doing more general like TEE education initiatives, because you all have so much domain specific knowledge about all this stuff. I feel like there is not a lot of information out there. I feel like ZK has been really kind of, a lot of people have done a lot of public open discussions and research. Maybe the same as for TEEs, but I just maybe I'm not in the right echo chamber. But I feel like it would be really cool to kind of see more of this, especially with you all kind of being so specialized and focused on this. But I've already learned a lot, and I'm hoping a lot of the people that watching kind of learned a lot as well. So that's just like a general thought. But before we dive into the next area, which is going to be more discussions around building the AVS specifically, Gajesh, just want to make sure if you had any other questions or comments before we moved on to the next final area.
Sure thing. Yes. So what apps would you like to see people build with Automata, which do not exist right now?
I think from my point of view, I would prefer people start building like a fairness like applications, because this is also what TEE is good at. It's able to actually enforce certain policies, no matter it's a public policy or private policy. So if it's private policy, then it means maybe it could be a private auction. Like a lot of like parties could like do this like in a really fair manner. If it's public policy, that means okay, this can be something like maybe a public good that really like ensures that all the participants get a fair share of the interest, or at least they could just contribute like to this equally. So this will be kind of the very interesting application. So so essentially people can build maybe DAO inside it, or if like in particular area that's interesting, that they could also make use of this. So this will be a very interesting property. And actually at the very beginning we started with this, but we haven't seen really like good applications going out.
So for myself, I'm actually kind of like I mean to kind of like add on to what Turley mentioned. There's actually a project called Cycles that is combining TEE with NPC to do things like what do they call it? Something like credit, a kind of like a credit system within the Web3 ecosystem. But I think for me, what I really want to see is actually like decentralized game. Like it's really like so for me, I'm a gamer myself, and what happens is that a lot of multiplayer games, you realize that once the company decides that, hey, I'm no longer going to support the game, and then that's it. That's the end of the game. We can no longer play it anymore. But if we actually have kind of like Web3 games, but well, nowadays Web3 games have a certain connotation, but as well I'll call it decentralized games, where users can actually have some way to establish like a kind of like a trusted server where no one can modify the data because it's running within a TE. And then the clients can all connect to this server. This server doesn't have to be hosted by one specific company. It can be hosted by anyone, or by a DAO, or by a community, or even on a distributed network. And then you can have, for example, your old Diablo 2 type games where you can have a mini session 8-player connect to this this server, or you can have like Quake 2 kind of like deathmatch kind of like tournament games. I'm actually really excited to see like more of this happening, because TEs provide you with this computation integrity and low latency, like high, what's it called, high efficiency in terms of like computation and latency. So I think this is a very good use case.
Very cool. Well, now we're going to wrap it up, but I want to talk a little bit about your experience building an AVS, or building as an AVS. So a lot of the people that are watching are maybe new AVS developers. So if you had any like advice or suggestions around kind of what you learned in building in the EigenLayer ecosystem, but also building your network in this fashion, because, you know, when you all started building, especially, it was very early. And, you know, we've come a long way since then, still trying to make it easier and better. But yeah, do you have any advice for any AVS developers?
Yeah, actually, we started the like talking to you guys. I think started last year, but like actually earlier this year, we started looking at AVS, looking at SDKs. It's actually great to see that everything is open source. Also, the documentation is very clear. So I wouldn't say we face any difficulty on like developing the AVS software, the node softwares. Also, like later on, like when we launch it, also we receive a lot of support, especially on acquiring the operators. So there are actually groups like helping us to like start like introductions and connections with all the different operators. So we're able to quickly get over like 20 operator at the beginning, and now slowly we grow to even like 70 plus. So this is actually quite amazing, and we receive a lot of support from everyone in the ecosystem. Also other like peer AVSs as well. So they've been also sharing their experience, helping us to like solve some of the issues, especially when it's related to the some of the newest like development, all the new features. Because we probably not the like following the like very closely sometimes, but we do get like help and updates on those things too. So that's really good experience.
Yep. So actually, my advice would be like, just go do it. Just like go clone the public source repository, and then just start building. And if you have, what is it called? Because I find that the community is actually very strong, and there's a lot of help. So just dive into it. What if you have any problems that you meet along the way, ask, and I'm pretty sure you'll get help and answers. Yeah.
That's the best life advice too. Just do it. Like professional advice, just do it. You know, like don't procrastinate. Just start building. You never know what's going to happen. You put one foot in front of the other, and good things happen. Because I think a lot of times, like what I've noticed is I get paralyzed by fear, or by worry, or by like think I'm going to make a mistake. So I just don't start. But if you just start, you know, things just work themselves out a lot of times.
Yeah, totally agree with that.
Awesome. Well, this has been really great. Again, thanks for both of you for coming on. I appreciate your time. I learned a lot, and I'm looking forward to other people learning as well. So if someone wants to learn more about Automata, we have the Twitter account here. But if they want to get started building or considering building, where should they go?
Yeah, actually, the best source is still some of the like our own like repo regarding the AVS that we built, because you could really get a sense like how TEs could be integrated with this kind of AVS system. But in the future, we'll be releasing SDKs for people who really want to like just experience with like the development of TE. or with or without ABS. I mean, this thing could be also just running standalone, but what they need is really might be some attestations modules that could help them to verify on chain. So this will be all available in the future releases.
Yep, and if there's something that you want to know more, we have a Discord. If not, most of our information can actually be found on our Twitter X. So, yep.
Perfect. Well, thanks again for coming on. Thanks everyone for watching. This has been another episode of Infinite Layers. We'll be back next week with another one. If you missed part of this, it'll be on our YouTube as well, and we'll try to drop a couple of links there. So thanks.